All right. Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and I am here to welcome you to today's webinar. Your app deserves more than Kubernetes Ingress. Kubernetes Ingress versus Istio Gateway. I want to thank you all for being here, and I especially want to thank today's presenter, Andrew Lee. Andrew, tell us a little bit about yourself.
Everyone, thank you for joining on your Tuesday morning or afternoon. My name is Andrew. I'm the technical instructor at Mirantis. I've been in our training team for the past 4 years, and more recently, we have been delivering Kubernetes courses. So we have our Istio course, our first Istio course coming up, and we wanted to give you some overview about, some of the features of Istio, which is today's topic, Ingress versus Istio Ingress versus Kubernetes Ingress. So please enjoy the presentation. I think Nick has a few housekeeping items.
Yes, a little bit of housekeeping before we go on. Yes, so as you will notice, there is a panel usually to the right-hand side of your screen. If you have questions as we go along, please go ahead, feel free to go ahead and add them to the questions pane. We're going to go ahead and save the questions for the end, but you don't have to. I'm going to go ahead and answer the most common question right now. Yes, you will get a link to the slides and to the video of the webinar after we are done. So with that, Andrew, I'll ask you to tell us a little bit about what we're going to learn today and then jump right in.
Sure. All right, so today we're going to have a short presentation, about 10 to 15 minutes, about what is Ingress, specifically the Kubernetes Ingress and the Ingress Controller. And then we'll discuss Istio's version of Ingress, which is called Gateway. After we have this discussion, I'm going to spend the rest of the time doing a demo of these two topics. All right. So first, we have to understand what is Kubernetes Ingress, right? And there are many ways to expose your app in Kubernetes. And if you have just started using Kubernetes, maybe you're familiar with a node port type of service, right? So you get your node up and running, and you expose a port on that node, which maps to your service, which then maps to your pod, right? In a more advanced scenario, you may have deployed a load balancer type service using your cloud provider, or even a Ingress with the Ingress controller. So we will look at these three types just in case you're not familiar with them. So here's what a node port entry point for your app might look like. So from the internet, I can access my Kubernetes node. And when I create a service type node port, it takes one of the ports from all of my Kubernetes nodes. It's showing one in this diagram, but all your nodes will have this node port taken. Now, when I talk to this node IP on this node port, by the power of IP tables, my request is forwarded to my application container. So it's a very simple and easy way to get up and running to expose your app, right? Now, the problem comes when we start looking at, okay, what are my end users seeing, right? I have this really cool application, and then I tell my users, okay, my app is available at 52.14.21.152:30126. So obviously, that's not really an ideal scenario to give to your end user. So one of the issues is that it's not a standard port range. Okay, the default port range for this node port is 30,000 to about 32,000. Okay, the other one is that we can only give one node port per service. So I just have one application exposed. If I had another one, I would have to create another node port service to expose that set of pods. Right, so it has this limitation. It's typically not for production use. So now looking at Ingress, okay, we still have our traffic coming into the node, except now our Ingress controller which is a pod in this case, our ingress controller is going to be the one doing the proxying. And that proxying is choosing which service to forward my traffic to, or the user traffic to. Okay, so in this case, I now have two applications, service A and B, and you would specify some rules about how to forward traffic to which service, and that's called ingress. So in fact, there's many components to Kubernetes Ingress that we'll look at. One being the ingress rule itself, and then the controller who's actually doing the forwarding. Okay. So in a full-blown production environment, we just wanted to give you an idea about the architecture. So typically you'll have some load balancer, which is the single point of entry for your users. That load balancer will pick one of your Kubernetes worker nodes, and then your ingress controller will be exposed by that through that load balancer service. Okay, but what we're going to do in the demo today will look more like this previous diagram, where we expose the host port. When I talk to the host port, I'm actually talking to the ingress controller. So keep that in mind. Okay, what's great about ingress is that we can do path and host-based routing. So I mentioned that earlier, that we can choose, or we can define how our traffic can be routed to service A or B. Well, if service A is some blog application and service B is some shopping cart, right? I can say, if a request comes in for mysite.com/blog, let's send it to service A. And that's done through the ingress rule. If it comes in for mysite.com/shop, let's send it to service B. That's defined through the rules, and we can just expose one port, but depending on the user request, we can send it to the correct service. So multiple services behind a single cloud load balancer, and that's the key. To do this, you need three components. So we have our ingress rule, which is the Kubernetes resource where we define that path-based routing. So we'll see that shortly in the lab. We have the ingress controller, which is the actual pod doing the proxy. Okay. And the most common and the recommended tool for that proxy is Nginx. Okay. Otherwise, if you're using cloud providers, they may actually implement this ingress controller in some different way in conjunction with a load balancer. So this acts on the ingress definitions provided. And then the default backend is where, if none of the rules match, if the request doesn't match any rules, it will be sent to this backend pod. Okay. Now this too has some limitations. So out of the box, okay, if I don't get some Nginx Plus subscription, there's limited observability tool sets available to my Kubernetes cluster. Okay. There's also no good way to do advanced traffic controls or release strategies. So if you think about, okay, let's send 10% of my traffic to version 2 and 90% to version 1, there's no way to specify percent-based releases. Okay, so you have some limited capabilities about traffic control. Okay, and also there's no service resiliency features either. Right, so keeping that in mind, let's take a look at Istio and how it can solve some of those shortcomings. Right. So primarily, Istio is the control plane for Envoy, and that's the way I like to think about Istio. And Envoy is going to be our proxy for the Ingress Gateway. All right, so think about Envoy as sort of the direct replacement for Nginx. So Envoy being more featureful, okay, let's put Envoy at the edge and then have Istio control and program Envoy. So rather than having Ingress Controller here, we now have a resource called Istio Ingress Gateway, which is another pod with Envoy container running. And this gateway is programmed by creating gateway Kubernetes resource and virtual service Kubernetes resource. Now these are defined as a custom resource, and we will also see that in the demo. So in similar fashion, we have service A and B, where we define the rules about how to forward traffic to which service. And you can imagine, we can also specify percent-based traffic routing as well. Now, what I've done here is highlight or put in Envoy in application A here as well. If you're not familiar with Istio, you will have what's called a sidecar container in every pod in your workload. So in fact, all of my application pods will have this Envoy container in each of them. Okay, and that's going to be your data plane. And we'll see why in just a little bit later. To utilize the Istio Ingress Gateway, you need 3 resources. Okay. You need the gateway resource. This is a custom resource definition, where you configure ports, the protocol certificates, if any, as well as a virtual service. So this is where you're defining your routes. So virtual service is very similar to the Ingress Kubernetes resource we saw from earlier, or it will be a replacement to that resource. And then lastly, you have your Ingress Gateway, which is the pod with Envoy that does the routing. Okay, so Ingress Gateway then is a replacement for Ingress Controller in the native Kubernetes. Okay. The advantages are that Envoy can handle layer 7 traffic, so can Ingress, but Envoy has additional advanced features as listed here. Okay, so things like more advanced routing rules, percent-based routing, distributed tracing, limiting the rate of traffic, checking policies, and one of the very important feature sets of Istio is that we're able to observe our microservices better, more holistically. So metric collection is also very simple when you have Envoy. Okay. It also natively supports gRPC. So if your applications use gRPC to communicate, then Envoy and Istio is a good choice. Okay. And secondly, there is dynamic configuration. So no longer do you update a config map and then restart your pod. So Envoy has a feature called hot reload, where you don't have to drop any traffic before loading a new config. And lastly, egress rules are also supported. And some disadvantages you may think of is that it requires yet another control plane component. So Envoy by itself, you can use it as sort of a data plane component, but it's easier to do so with a control plane like Istio. So then it requires you to sort of learn this new tool and new commands and how it works. Another thing is that if you talk to a company or a product like Ambassador, they'll say, well, Istio is primarily for internal traffic management. It's for your service mesh. It's not specialized for exposing traffic to the outside. It's not for north to south. Rather, it's more specialized for east to west communication. So that may be a disadvantage. So some alternatives. There are tool sets called API gateways, which do specialize in this north to south edge traffic, which are Ambassador. You may have heard of Traffic or Calm. Now, these are mainly commercial products, whereas Istio and Envoy specifically is a completely open source product under the CNCF. Right. Okay, so without further ado, let's take a look at the demo overview. Okay. We're going to have an application which gives us some cat GIF, and we're going to progressively expose it by better and better methods. Okay, so we'll start with node port, and then we'll move on to Kubernetes Ingress, and we'll take a look at what domain name is configured, and we will live install and configure Istio into our Kubernetes node. And lastly, we'll look at the Istio Ingress Gateway, and as a bonus, we'll take a look at what observability features are available using Istio. All right. So here I have my environment. This is just a single node Kubernetes deployment. Right now, there's nothing deployed on here except the Kubernetes control plane. So if we do get pods on the kube system, we have our Kubernetes components running. What I'm going to do is navigate to the manifest directory. And here I have an application called Flask, that's ready to be deployed. So the basics of this app is very simple. We have a front-end Flask service, which serves the Flask app pod, and it's a Python code which retrieves cat GIF URLs from Redis. So we'll go ahead and deploy this and see what it looks like. First thing we'll do is deploy the backend first to make the cat GIFs available. So we'll apply the Redis app first. And while it's deploying, let's take a look at the deployment spec. You can see we have a service, type cluster IP. This Redis service does not need to be exposed outside, so cluster IP type is fine. Then we have a deployment of the Redis app. Okay, we're going to have a mounted volume, which then is going to serve a Redis configuration that we passed in as a config map earlier. And this is not part of the recording, but I have created this config map with the Redis com inside. Okay. So let's take a look at that pod. It's up and running. And let's go ahead and deploy our Flask app deployment. And the Flask app deployment YAML contains the node port type service, which we will use to access this application, as well as the Flask app container. Okay, so let's look at our pods now. Now we have our Flask deployment and the Redis deployment running. What that means is we can now go to get services, and we'll notice that our Flask service has a node port associated to it. Okay. That means if I go to my IP address, which I've assigned the domain name for, so it's andrew.mirantis.com, and I go to the port 32015, which matches the node port, then I should get my application. So this is my cat application. Later we'll deploy a dog GIF. But for now, we just have cat GIF of the day. Okay, so that's a very simple way to get up and running with Kubernetes to expose my application. But as we discussed in the webinar, one of the issues is that, well, this is not a standard port. Okay, and we can have different ports, or we must have different ports for different applications. So now what we'll do is create an ingress resource, and that'll allow us to do path-based routing. Okay, so let's take a look at the ingress manifest, ingress cat dog. And this is saying anything destined for the /cats path, let's send it to the Flask service. Anything for /dogs, let's send it to the Flask dog service. But that doesn't mean we're going to go to two different hosts. We're going to still be able to go to andrew.mirantis.com but depending on the path that we request, will be forwarded to a different service. So what we'll do now, we'll deploy our dog application. ASCAP dog. Okay. We'll make sure that's running. It's being created, and the last one is running. So let's go ahead and apply the ingress rule. This one, ingress cat dog, and now our ingress is created. Because we already have the ingress controller, this is the name of the ingress controller, we have this pod up and running. It's ready to enforce this rule. And so if we do describe ingress called cat dog ingress, we should see that this is being served by the controller. Okay, and then this ingress resource also has an address. Now it's ready to be used. So then let's go back here. Okay, go to port 80, standard port. So my browser doesn't quite like the fact that it's a standard port, but it doesn't really recognize it. But we will proceed and ignore that error for now. So since I didn't specify any path right now, we're getting the default backend. So that's the desired behavior. But if I specify cats, okay, I get my cat GIF of the day. That's our cat service. If I go to dogs, right, and I get our dog GIF of the day. Right, so that's the power of ingress, having the single entry point on a standard port, but being able to do path-based as well as the host-based routing. Okay, so it's very simple to do, and all it took was a deployment of the ingress controller as well as the ingress rules that we created. Right? Okay. So then how do we go about deploying and creating ingress rules for Istio? So what we're going to do is first take a look at the Ingress Nginx namespace, and this ingress default Ingress Nginx will actually interfere with Istio Ingress Gateway. It's going to try to take the same port 80 from the host. We're going to just get rid of this namespace entirely, as well as delete the ingress resource. So do some housekeeping cleanup. Delete ingress. We'll delete the cat dog ingress. And then we'll delete the ingress namespace as well. Ingress Nginx. That'll take a second just to delete all the resources. Afterwards, we'll take a look at installation of Istio using Helm charts. Just a few more seconds and our ingress namespace should be deleted. There we go. Okay, so the next step then is to download this repository. Now, if you are following along from home, this is just the standard Istio version 1.1.9 that we've just downloaded from the internet. Okay, and it comes with these Helm charts. The first one we're going to run is for it's called Istio init, and that's going to initialize my custom resources. And by custom resources, I mean if we do kubectl get crd Istio system. Okay. Let's see, that's not the list I was looking for. Right? If we do get crd, you see that there's a lot of these custom resources with the Istio suffix. And these are all related to Istio. right? So this will allow us to then later on install Istio and have Istio manage these resources. The next Helm chart to run is the actual control plane components themselves, right? And so this one will spawn all of the Istio control plane components with the following options: gateway type node port, Kiali enabled, Prometheus enabled, tracing, Grafana, and so on. So pretty much everything enabled. We're going to run that. And that'll take us a few moments to install as well. Okay. So eventually what we want to get at is have the Istio control plane and take a look at the Istio Ingress Gateway and be able to forward traffic to our existing dog and cat apps. Instead of using Nginx, we want to use Envoy. So it looks like it's been deployed. Let's look at the Istio system namespace. Right. So a couple of my pods are still coming up. Okay. Some are still being created. So let's give it a moment. Get the pods. Okay. Now the egress gateway is running. Sidecar injector is still being created. So is Prometheus. Prometheus is running and Ingress Gateway is running. So we should have all pods now. Fairly quickly. Okay. The first thing I'll do right now is if you take a look at my existing workload, right? They each have one container, but in an Istio enabled environment, all of my workload pods should have two containers because each of them will run Envoy sidecars. And Istio makes it really easy to automatically enable injection. And that is the following. We're going to label whatever namespace my workload is running at. In this case, it's default. We're going to put a label on it called Istio-injection is enabled. Okay. Now, that's not going to change anything just yet. What we need to do is actually do delete the pods if they already exist. And we'll just let the replica set controllers recreate the pods. Okay, and that way they will actually come up with two containers. Now, there are some dependencies between these applications. The Redis should be up and running first. So we will see, we'll take a few seconds, a couple minutes to wait for these pods to come back up. So let's take a look right now. Okay, so we now have all the pods with two containers. If you describe them, you'll be able to see what I'm talking about. So describe Redis app, describe pod, that is. And you see that in the containers field, there's a new container called Istio proxy. That's the one that is the sidecar, which is handling your traffic for this pod. Okay, and that is the Envoy container that's running within the pod. Okay, okay, our workload is ready to go with Istio. And so we're going to go ahead and start working on the Ingress Gateway of Istio. Now the Ingress Gateway has already been deployed for you. If we go to Istio system namespace, you can see that we have an Istio Ingress Gateway pod, right? Now for this demo specifically, let me show you one thing. We're going to edit the deployment spec of Istio Ingress Gateway, and we'll actually map the host port 80 to this pod directly, to the Ingress Gateway directly. That way, any traffic coming to the host will be forwarded to this gateway pod. Otherwise, we would probably create something like a load balancer service and then ensure that the load balancer forwards it to this gateway. But this is just one way of doing it, and is for demo purposes. Okay, but we will put a host port here and save that spec. All right, our Ingress Gateway pod is set up. What we'll do next is start configuring the gateway. So let's go back to our manifest directory. I said that in order to use Istio Gateway, you need to create both the gateway spec and a virtual service spec. Okay. Gateway will configure my host and port for this pod, and then virtual service will configure the rules. All right, so I have both of those here. My cat dog gateway will expose port 80, protocol HTTP, and my host name will be andrew.mirantis.com. My virtual service will look like the following. It'll utilize that gateway, but also we have a couple rules. Right? The first part of the rule says, if the user request header, user agent header, matches Chrome, then let's send it to the dog service. Okay. Otherwise, for any other request, let's send it to the regular cat service. All right. Let's go ahead and apply those two resources on Kubernetes. Go kubectl apply cat dog gateway and apply dog Chrome virtual service. Okay, so we now have our gateway resource and the virtual service resource. So now, if I go back to my website, just the root directory, so I navigated to andrew.mirantis.com. My browser is actually forcing me into HTTPS. So what I'll do is open a new incognito window and go to the site directly again. Okay. So because this is Chrome, I'm getting dog GIF of the day. And if I open a new browser that is not Chrome, here's Safari. Okay, Safari will get the cat GIF of the day. And this is all thanks to our virtual service, which is routing our traffic to respective services, right? And that is the power of virtual service. All right, so the last thing that we kind of looked at in the live demo, but I want to show you again just in case, is to retrieve the Kiali dashboard. And Kiali will allow us to visualize our microservices. So as a bonus, let's take a look at the Kiali observability tool. I will just expose it as a node port. So let's go ahead and do that. Edit service, Kiali. Okay, change the type to node port, like so. And that service is live. And let me make sure that I have my secret. Okay, it's called Kiali. Okay, I have my Kiali secret with the admin dashboard credentials. So the location of Kiali is then the service IP, and then the node port. So go to that node port /Kiali. And here's that console. Log in with admin, and that's from the secret that we created earlier. And what's great about Kiali is that we have various views we can select. Today's focus will be on the graph view. And so we want to select the namespace, and our workload is that default namespace, so we'll select that one. Now, when no traffic is flowing, it doesn't look particularly flashy. So what we can do is actually run some commands to simulate traffic. So we'll do a while loop of curling the domain. And we will also curl as Chrome, right, on andrewmirantis.com. And let's curl another resource. And this time we will pass in an invalid URL just to see what happens. While that's going, it's running some curl commands against my service. And shortly I will see some response from Kiali. What's great about Kiali is that I can see exactly where the failures are occurring. So for example, my 400 errors, which is the path not found errors, are happening at the Flask service, going to the Flask app, right? And we can see that our dog app is returning fine, so we know that we can pinpoint our efforts to debug into our Flask service and the Flask app. So in fact, I'm going to cancel that for a sec. What we can do then is get the logs of one of our Flask app deployments to see what is going on with this deployment. Kubectl logs, not get logs. And we will select the Flask app container. And so, because we've been able to easily pinpoint where it is, we can see that a couple users have been pointing to this location called invalid, /invalid. Otherwise, our requests have been returned with 200. Okay, so you can start to imagine as you have bigger applications, bigger microservices, more dependencies, this graph view will come in very handy. And even if you're an operator who is, I guess, new to the team, new to the application, you can get a very good overview of what the architecture looks like. For example, we can see here that our cat application actually retrieves from Redis, whereas our dog application does not. Okay, so the dog GIF URLs are embedded in this HTML, whereas Flask app is not. So that's all I wanted to show for today. Thank you for watching.
All right. So let us go on. Because you're here, we want to thank you for being here, and we're going to get into questions in a minute. But Andrew, if you could go to the next slide. The training department has offered a 15% off discount. You can use this coupon code. This is your reward for sticking around till the end. You can see here we have Kubernetes classes. Actually, Andrew, you could probably speak to what these classes are a bit more than I. I know we've got some syllabi available in the handouts section. But you want to tell us a little bit more about these courses, Andrew?
Yeah, we have the handouts available. Basically, if you're new to the Kubernetes world and you want to get an introduction, then the KD100 class is a great place to begin. I know that CKA is and has been a hot topic, and so we have a course to prepare you for the CKA as well. So if you sign up for the 250, KD 250, that's a great comprehensive course, starting from knowing nothing about Docker and Kubernetes to being able to pass the CKA. And more recently, we have a Istio training coming up this week. And so the first course will take place this Thursday. So that'll be our introduction to Istio and the service mesh. And then talking more about
You're teaching
Microsoft.
that, aren't you?
That's right. I'll be teaching this one.
Okay.
And the second day will focus on security, resiliency, and monitoring using Istio.
Fantastic. Okay, so again, training.mirantis.com. You could use that that code WebMirror 2019 for a 15% discount. All right, so let's get into Q&A. If you have not submitted questions, now is a good time. Oh my goodness, I see we've got a bunch of them. Let me get to the list and we will take a look. All right. So how resource intensive is it to run Istio in your Kubernetes cluster?
So I found that in the demo environment specifically, it was pretty intensive for me. So let's take a look. We can do describe node. Right now it's using about 2 virtual CPUs and about 70% of my provisioned memory. Okay, so I found it to be pretty intensive to run the additional control plane component, but of course it will help to have your additional Kubernetes nodes. But your master nodes may become quite a bit larger because of the additional control plane components you're deploying.
Okay. All right. Is Istio the only way to have Envoy proxy at the edge?
No, because let's see. So when we talked about some of the alternatives, these guys, like Ambassador is a product where it's still using Envoy, but it's just a different control plane component. So Istio is not the only way. There are definitely alternatives on the market.
Gotcha. Okay. Are these classes online or at a campus?
These classes are both online and available on site. So we have public classes, which are periodically scheduled throughout the weeks, and those are both virtual and on site. So for the same session, you can pick and choose whichever method of delivery you'd like.
And I've actually taken some of these classes virtually. It's very convenient.
Yeah, absolutely.
All right, let's see. If the main difference between Kubernetes Ingress and Istio Ingress is Nginx versus Envoy, why is Envoy better?
If the main difference is Nginx versus Envoy, why is Envoy better? So Envoy is more featureful than Nginx, and it's not as sort of blocked behind the paywall, or where it's more community driven, and many of our current big companies like Google and Lyft are adopting Envoy and contributing back to its code, and this is a great ecosystem to get into currently. So you can see that when we talked about advanced routing rules, the tracing, the metrics view that we saw in Kiali, these are all available because of Envoy's features. Okay, so go ahead.
No, I was just going to say, you've said that Envoy is more featureful. Could you give us some examples of that?
Yeah, so some of these metrics that we're gathering about how much traffic is being sent, for example, the request percentage, these are all kept track by Envoy. Because Envoy is right at the data plane, and it is the medium in which your microservices communicate with each other, it can see all the communication channels between all of your services. Okay. Whereas with just pure Kubernetes, maybe you'll have to install some additional metrics toolsets in order to see this kind of info. And the same thing applies to the edge. If you just have Nginx, well, maybe you don't have as much visibility and features as Envoy.
Okay. Could you just use Envoy as the Ingress controller without Istio?
So I think that's a similar question as before. If there's alternatives to Istio. Another one that I found is called Contour. So without having other custom resource definitions from Istio, Contour is a good project. We're still using Envoy proxy, but it's going to be implemented in a different way than Istio. So it's a little bit more lighter weight. If that's what you're looking for, then maybe that's a good option for you to look at.
Okay. Will it be possible to deploy Istio pods with MCP 2.0 GUI?
Yeah, definitely. Well, when you say MCP 2.0, I'm guessing you're talking about our CAS. And so in our CAS product, we'll have a checkbox to deploy Istio, and that's about all you need to do.